Let's take a look at the practice questions that deal with the area of a triangle and area of other figures. So when we look at question number 1, it says if Jan wants to tile her bathroom with 1-inch tiles, how many tiles will she need if her bathroom with the given dimensions are shown? So we have this irregular figure here, but it's really nice that we have the 1-inch tiles. That's going to make the calculations a little more straightforward. So we're wanting to know how many tiles, so we've got to fill this area within here of this irregular figure. And so to me, it's a little bit easier if I can split this up into 2 rectangles. And I'm going to split it up right here. And this figure up top, if this length here is 5, the whole thing is 10, it will make this length 5. So we have an area of 5 by 5 for this top. It turns out to be a square. So now for the bottom rectangle, we already have the dimension of 8 for the length. So we've got an 8 by 5 rectangle. So for the 1-inch tiles, we're really just going to be looking at the area inside this irregular figure. So the area of the top of 5 by 5 is just 25. We'll say the area of the top. And the area of the lower portion is an 8 by 5, which is 40. So we'll take these 2 areas and we can add those up and we get 65. So Jan's going to need 65 tiles to fill that area. Question number 2, in the figure, the vertices of triangle ABC have coordinates 3, 2, 4, 5, and 7, 2. What is the area of triangle ABC? So since we're doing area of a triangle, the first thing I want to think about is what is that formula? And remember, for a triangle, it's 1/2 base times height. So if I know the base and the height, I can do that. When I'm looking at this triangle between A and C, that's going to give me my base. I don't have a right triangle, but I can make one, and that will give me my H. So what are those values going to be? Well, I know that A is the point 3, 2, and B is the point 4, 5, and C is the point 7, 2. So I can use these coordinates to figure out my B and my H. So the length of AC is the difference in the x coordinates of A and C. So we go from 3 to 7, that's a difference of 4. And for my height, I can use either A or C with respect to B, looking at the y components. We went from 5 to 2, so 5 minus 2 is going to be 3. So that's my height. So I can go back in and plug into my formula here. My base was 4, height of 3, 1/2 of 4 times 3 is 1/2 of 12, which gives us 6. That is answer choice G. Now let's take a look at number 3. In the trapezoid ABCD, which is given here, AB is 8 units long, CD is 12 units long, and EF is 5 units long. Also, the angle AEF and DFE are right angles. What is the area of ABCD in square units? So we know ABCD is a trapezoid. And the easiest thing to do is if we can remember the formula for the area of a trapezoid, it is equal to 1/2 the height times B1 plus B2. What are those values? Well, my height is going to be given here EF, and we're told right here that EF is 5 units long, so I can label that. B1 can be AB or DC, it doesn't matter, but we'll have AB equal to 8 units. That was given it to us here in the question. We'll say that's B1. And we'll say B2 is along the bottom, CD, which is given as 12 units. So we can just plug that in to our formula of 1/2 H, which is 5, times B1, 8, plus B2, 12. When we simplify, 1/2 times 5 times 20, that's going to turn out to be 50. That is answer choice C. Now let's take a look at number 4. What is the area in square meters of the shaded region? So we're looking at this top region right here. When we're looking at area of a rectangle, it is length times width. Let's see what we have. Looks like we have the length here of 16, so I can plug that in. What about my width? Well, I'm given the total width of 15 of this total irregular figure, but over here I'm given this value of x, this length up to the shaded region is x. So that would make sense that the length of the shaded region is just going to be 15 minus x. I'm going to have an x in my final answer, which, as you can see when you look at the choices, some of them do have x's. That's okay. So we can think outside the box when we're looking at this. Let's multiply out because we don't have one of our answers that looks that way. So I'm going to have to distribute that 16, and I get 16 times 15 is equal to 240 minus 16x, and that looks like answer choice G. All right, let's look at the next page of these questions. We'll start with number 5. If the area of a triangle is 35 units and has a base of 10 units, what is the height of the triangle? So we're solving for one of the pieces of the triangle. We remind ourselves that the area of a triangle is 1/2 base times height. We can plug in what we know. We know that the area is 35. They gave us that part. And they also told us that the base was 10. And we're looking for our unknown value of height. So h is our unknown. So we're going to simplify here. I get 5h. So I'm solving for h, so I want to divide through by 5, and I get 35 divided by 5 is 7. And that is answer choice B, 7. Number 6, what is the area of the equilateral triangle with side lengths of 10 feet? So knowing that this is an equilateral triangle, we know that it has 3 sides of the same length, 10 by 10 by 10. Okay, but we need to remind ourselves the area of a triangle, again, is 1/2 base times height. When I'm looking, I'll draw a larger version of that triangle. When I'm looking at my 10, 10, 10 triangle, I know a base is 10, my base length, but what about a height? When I'm not given a right triangle, which we don't have a right triangle when it's an equilateral triangle, I can draw my own height here, and that's h, but I'm going to have to look at these individual triangles to figure that out. So let's just we'll take a look at this right-hand side that we pulled out. And now we know that is our h value. We know this hypotenuse now is 10. But what about this length here? Well, when we draw this leg down here, will come from the center of this angle, it's going to split that base in half. So now this particular triangle, this right triangle, has a base of 5. Now, we can use Pythagorean theorem to solve for h, and we know that we have 5 squared plus h squared equals 10 squared. So we have 25 plus h squared equals 100. We want to solve for h. We have h squared is 75, and we'll take the square root of both sides, and we can have that to be 25 times 3. And when we take the square root of 25, that is 5, and leaves us 5 on the square root of 3. That's the value of h. Now we can go back to our original formula and plug that in right here. So I'm going to do that over here. A equals 1/2. Now remember, we've got to use our original base, which is 10. Don't get it mixed up with the base here, but we're going to use our original base of 10 times our height, which was 5 on the square root of 3 that we calculated. And when we do our simplifying here, we're going to get 25 on the square root of 3 as our area, which is answer choice G.